For our formula number 26, we will find the differential of u to the v is equals to u to the v, take the differential of v ln of u. So that is our formula number 26. So we have here problem, find dy dx if y is equals to x to the x. So to solve it, just apply the formula. So we have y equals x to the x. So our dy dx now is equals x to the x times the differential of x ln of x. So as you notice, this is product rule. So we have x to the x times, copy the first, differentiate the second times 1 over x, plus copy the second, differentiate the first, so times 1. So we have now x to the x times, cancel out, we have 1 plus ln of x. And that is your answer. Find dy dx if y is equals to sine of x to the x. Again, just apply formula number 26. So to solve it, we have y equals sine of x to the x. So dy dx now is equals to sine of x to the x, then take the differential of x ln of sine x. So we have now sine of x to the x. Again, this is product rule. We have x times 1 over sine x times cosine of x plus the natural logarithm of sine x times 1. So we have now sine of x to the x times x cotangent of x plus ln of sine x. This is now your final answer. So our topic is the differentiation of exponential functions. So we are now on the 27th formula for differential calculus. So we have the differential of a to the u is equals to a to the u, just copy, then multiplied by the natural logarithm of a multiplied by du dx. And for the differential of e to the u is equals to e to the u du dx. Just copy the e to the u, then differentiate the power of the e. So for our problem number 1, we have find dy dx if y is equals to 4 to the 2x. So as you notice, this one is similar to this one. So a to the u. So your a now is a constant. So to solve it, y equals 4 to the 2x. Our u here is 2x. Our du dx is equals to 2. So we have now our dy dx now is equals to a to the u. So just copy 4 to the 2x multiplied by the natural logarithm of a. What is our a? Is 4. Du dx is 2. Okay? So you have now 4 to the 2x times the natural logarithm of 4 times 2. So we have 4 to the 2x. This, you can bring this to the other side. So this now becomes 2 natural logarithm of 4. Okay? So we have now 4 to the 2x. This can be expressed to the natural logarithm of 4 square. Or we have now 4 to the 2x of the natural logarithm of 16. And that is your answer. Okay, for our second problem, we have find dy dx if y is equals to e to the sine 2x. So, to solve it, our y is equals to e to the sine x. Our u here is sine x. Our du dx is cosine x. So, applying now our formula, we have now dy dx is equals to e to the sine x times cosine x. So, we have now cosine x times e to the sine x. Find dy dx if y is equals e to the x times e to the ln of x. So here we have y equals e to the x times e to the ln of x. Or we have y equals e to the x plus ln of x. Our u here x plus ln of x. Our du dx is equals 1 plus 1 over x. So from that, we have dy dx now e to the x plus ln of x times our du dx 1 plus 1 over x. Here you can have e to the x plus ln of x. Your LCD is x, you have x plus 1. And here, we can say it is e to the x times e to the ln of x. X plus 1 over x. Again, from trigonometry, e to the ln of x is equals to x. So, we have now e to the x, e to the ln of x is x. So, times x plus 1 over x. You can cancel out this 1. So finally, we have e to the x times x plus 1. That is your final answer.